All right, I'm chatting today to Aubrey De Grey. Aubrey works on the development of medical innovations that can postpone potentially all forms of age-related ill health. His main focus is on rejuvenation, that is the active repair of various types of molecular and cellular damage, which eventually cause age-related disease and disability with people, as opposed to the mere accumulation of such damage. He's a chief science officer of SENS, SENS Research Foundation, a California-based charity that undertakes and funds such research, which help reverse aging. He's the VP of New Technology Discovery of AgeX Therapeutics, a biotechnology startup developing new therapies in the field of biomedical, gerontology, and also an editor-in-chief of Rejuvenation Research, the highest impact peer-reviewed academic journal focused on postponing aging. So, Aubrey, welcome to the show. It's a pleasure talking to you.
Thank you. Thank you for having me.
I thought we can start maybe from you sharing a bit more about your bio background for people who don't really know you. It'll be great to hear.
Sure. So my background is I grew up in the UK. I spent probably half my life living in Cambridge, UK. And initially, I was not actually a biologist. I was a computer scientist. I worked for several years after my degree on artificial intelligence research. And during that time, I met and married a biologist. And through that, I ended up not only learning a lot of biology, but also discovering that biologists in general were not very interested in aging and were not really trying particularly hard to do anything about it. And I thought that that was quite scandalous. So eventually I decided that it would be sensible for me to switch fields, and I happened to be in a position where I could do that in the mid-90s. And since then, I've been working on the biology of aging. Around the year 2000, I had a kind of eureka moment, realized a quite fundamental thing that my colleagues were overlooking in terms of how to defeat aging with medicine. And basically, I've been working in that direction ever since. The idea that I had back then, which was something you've already touched on in your introduction, namely the idea of comprehensive repair of the damage that the body accumulates through life, is something that started out being quite heretical, I guess, but it's now a very mainstream concept. It's being reinvented by other people and so on. And of course, we've also made considerable progress in actually implementing it, both the work that has been done and funded by SENS Research Foundation and also work that other people have done aligned with that.
Mm-hmm. Can you share maybe more about the work you're doing and the things maybe you've discovered so far, which are helpful to reverse aging?
Sure. So SENS Research Foundation is a research organization, which means that we don't take things all the way to the clinic. What our focus is on is doing the early stage proof of concept work that gets things to a sufficient point that we can spin them out into startup companies, for example, and they can be taken forward typically in the private sector with considerably better funding for investors than what we would be able to provide philanthropically. And that, of course, leads eventually to clinical trials and so on. So the work that we've done over the past 10 years or so since SENS Research Foundation was set up has focused on a number of different types of damage that accumulate throughout life, based on the kind of classification that I first started describing in the early 2000s of the types of damage of aging into 7 major categories. And we've worked on pretty much all of those categories over the years. I think if we look at each of them in terms of the contribution that we've made, they fall into certain stages. So, for example, one thing that we've been working on is the elimination of waste products that accumulate either inside the cell or outside in the spaces between cells. And there are now 3 examples where we have taken projects of that kind and moved them forward sufficiently far that we have been able, as I said, to spin them out into startup companies that have successfully attracted considerable investment and that are moving very rapidly towards clinical trials. The philosophy, the concept that we pursued for getting rid of waste products that accumulate inside the cell was something that I first suggested way back in the late 90s. And it involves using enzymes that do not naturally occur in the human body, but rather we find them in bacteria that are in the environment. And the approach for getting rid of garbage that's outside the cell is something that was first pioneered again around the late 90s by other people, that involves essentially stimulating the immune system to get rid of the things. So you can see it's quite diverse, the kind of approaches that we use, and in some cases quite innovative, but we are very proud of the successes that we've had. If we go and look at some of the other categories of damage, then again, these are approaches that we have not necessarily pioneered conceptually, but we have been the people who have been really spearheading their progress in the laboratory. So, for example, one a very major case is the accumulation of mutations in our mitochondria. The mitochondrion, for those of you who don't know, is a very important part of the cell that performs the chemistry of breathing, extracting energy from nutrients by combining those nutrients with oxygen. And that's a really bad place for DNA to be because the chemical reactions that are involved are quite toxic. So we are essentially putting backup copies of that DNA into the nucleus, modified in such a way that it still works even though it's in the wrong place. This is a concept that was first put forward in the mid-80s, before I had come along, and people basically hit some roadblocks and decided it was too hard and gave up. And we're pretty much the only people who've been pursuing it lately, and we've been very successful over the past few years. We published quite a significant breakthrough a couple of years ago. We've made massive progress since then, and actually we have a paper currently in review that reports that we are most of the way towards getting this to actually work.
Interesting.
Another example would be the loss of elasticity of tissues like the major arteries and also the skin, and indeed the lens of the eye that happens throughout life. That is the consequence of a chemical reaction that occurs between the proteins that confer that elasticity in the first place and sugar in the circulation. And the chemistry of all of this has been relatively well understood for some time, but the idea of actually doing anything about it and kind of breaking the molecular crosslinks, the molecular bonds that cause this elasticity to decline over time, that has been something that, again, people basically gave up on, and we've found a way through that. This was work that we didn't do in-house. We actually did it by supporting a fantastic group of researchers at Yale University, and they made some great breakthroughs. The first one was published in Science magazine a few years ago now, and again, that is in the process of being spun out into a startup company.
Mm-hmm. Very interesting. You mentioned a few different damage types, like one of them is damage and removal of toxins, it's mutation on the cells, and you mentioned you had a few breakthroughs in research on those things. What are some of the things you found out that can help in those examples? Of those specific supplements, lifestyle choices, or what is it that you found that is able to help actually reverse the damage?
We haven't found anything like that. We're not looking for anything like that. You know, lifestyle and diet optimization may be able to have some modest effect in some cases on the rate at which damage is generated, of these various types of damage that I'm talking about. Okay. But we're not really focused on slowing down the rate at which damage is generated, not least because we recognize that even in the best case, we would only be able to slow it down by a very modest degree. What we're focused on is repairing damage that's already been created, which of course it constitutes genuine rejuvenation, actually turning back the clock and making people biologically younger again. It's obvious that if we can do that, then we have a much more powerful and much more useful type of therapy, because it can be applied to people who are already in middle age or older. But what's not so obvious is that the repair of damage is actually a great deal easier than the retardation of the damage creation. And that was really the big fundamental concept that I first introduced nearly 20 years ago, and that is now, as I said, pretty much well accepted.
Mm-hmm. And what are some of the things you've tried or you found out is able to help the regeneration?
Well, I mean, it's all really high-tech stuff. You know, we work with stem cells, of course. We are very focused on gene therapy for a variety of different conditions. And one of our major projects involves developing a kind of new generation gene therapy mechanism that will be much more powerful, both in terms of safety and efficacy, than anything that exists today. So we're very focused on, doing things that can't be done yet. This involves, of course, also innovative approaches to other things that sound more traditional. So, for example, the approach that we've taken using the immune system to eliminate waste products outside the cell involves using a very special type of antibody that doesn't simply bind to the thing it's recognizing, it actually chops it up. So it's what's called proteolytic. And that means that it can work much more powerfully independently of other aspects of the immune system.
Mm-hmm. Very interesting. And how fast do you think some of those things may be available to the general population? Some of those high tech, I know stem cells, for example, is very expensive still. So when do you think some of the things you're finding out will be available to everyone out there?
Well, so first of all, let's talk about what is available right now. So you're quite right that there are some stem cell therapies being provided by certain clinics and so on around the world. And in general, they're pretty expensive. There's a pretty good reason for that, which is that they don't really do all that much. In some cases, they are somewhat beneficial to certain aspects of age-related ill health, but there's a long, long way to go. Now, the thing about that that's important is that the further we get, the more effective our therapies become, the more demand there will be for those therapies. And that will translate, of course, into reduced expense, both in terms of simply market pressure. In other words, there will be more incentive to reduce the price and make it more available. And also in terms of government pressure. In other words, there will be greater support for subsidy of these medicines via taxation. And of course, this will vary depending on the jurisdiction, but I'm quite sure that once we get to the point where these therapies are truly comprehensive, that even the most tax-averse societies like the USA, for example, will ensure that these therapies are available irrespective of the ability to pay, simply because they will pay for themselves so rapidly and so many times over by virtue of keeping people healthy and keeping them able to contribute wealth to society. At the stage we're at now, the therapies that we think are likely to be most effective are not even available at all, even expensively. The furthest that they have got is that some of these things are now in clinical trials, but typically quite early stage clinical trials. For example, stem cell therapies for Parkinson's disease. That's a trial that's only been going for a year in Japan. There are other trials starting up for the same kind of approach. Then it's been quite well publicized that a company here in the Bay Area called Unity Biotechnology last year initiated a clinical trial for their drug that can eliminate what are called senescent cells that have got into a kind of deranged state where they're doing more harm than good. And that trial reported its first results just a few weeks ago. Very, very encouraging results. But of course, still, that's only the first clinical trial. They still have a lot more to do before that will be available. Most of the, several of the therapies that we've been doing the early stage research for have got nearly to that point. In other words, they will probably enter clinical trials this year or next year. And even the most difficult ones that I was alluding to earlier, like, for example, making backup copies of the mitochondrial DNA, we would hope that those things will be in clinical trials within a few years.
Mm-hmm. Interesting. And what do you think is available right now? Meaning not something which is in trial, but something which everyone can potentially use today, as if we're recording it in 2019, to potentially reduce aging. But you're aware of if it's effective.
Yeah, there really isn't anything. Of course, there are easy ways to shorten your life, like, smoking or getting seriously overweight or whatever. But if we ask, what can you do over and above the situation that would exist if you just do what your mother told you to, then really we are not in a good position right now. And that's why people like SENS Research Foundation have to exist, of course. At the moment, there are some things which may be able to modestly postpone very slightly, like a couple of years if you're lucky, the health problems of late life for some people. But the difficulty there is that we differ too much. Different people have different metabolisms, and so you kind of, there's no general advice that can be given. One can only say, pay attention to your body, do what works. Some people benefit considerably from intermittent fasting, for example. Some people may benefit from certain supplements. There are some people who are unlucky and who, for whatever reason, maybe genetic, they have an unusually rapid rate of accumulation of one particular type of damage. Like, for example, there are some people who can come down with type 2 diabetes in their 30s. That's pretty rare, but it's not unheard of. People like that, there are possibilities for at least somewhat normalizing one's rate of aging using simple dietary supplements and so on. But for most people who are already doing averagely well, and especially for people who are doing unusually well, at the moment, we've really got nothing. And that's why it's so desperately important to hasten the development of the therapies that we're working on.
Really, you think that all the things which are available to us today, including stem cells, which I heard a lot about, I haven't done it myself, nothing can really postpone our lives in a big way. It's only going to add a few potential years.
That's right. I mean, you shouldn't be surprised about this, because look at the diversity that we have around the world. Every kind of conceivable lifestyle exists, right? Sure. And of course, we've also got plenty of diversity at the genetic level. And yet, across the whole developed world, the range of lifespans that exist is tiny. The USA, for example, is around about number 45 or something like that in the league table of longevity. But it's only 5 years less than 5 years, in fact, less than the number one country, Japan. And if we look around the world at specific locations, like specific regions of countries that have a reputation for being long-lived, they're often called blue zones, then again, we're only talking about a small number of years of difference.
Mm-hmm. Interesting. And how long potentially do you think the human lifespan can be extended with some of the tools and some of the things you're working on, assuming they end up being really effective in all the clinical trials, and potentially where do you see it going?
Oh, well, I mean, once these therapies get to work, there is no way that one can put a number on that. There should be no limit whatsoever, because the whole point is that we can periodically repair the types of damage that the body is generating as a consequence of its normal operation. And all we need to do is to keep the overall load of damage, the overall amount of damage, down in the region down below the threshold that's bad for us. Because, of course, you see, the reason why we don't get sick until late life is not because the damage suddenly starts to be created in our 50s or anything. The damage is being created as an inherent consequence of our normal metabolism since even before we're born, throughout our lives. And so the only reason we are perfectly healthy until late life is because the body is set up to tolerate a certain amount of that damage, which means that if we are repairing that damage, eliminating it periodically, and keeping it below that amount that the body is set up to tolerate, then we won't get sick. And if we don't get sick, obviously, then our risk of death is the same as it is in young adulthood, which is determined by things that don't have to do with how long ago we were born. Things like how safe the roads are and whether the planet gets hit by an asteroid and such like.
Huh. Interesting. Until which age you think you are going to live, based on kind of what we have known today and maybe what may be developed in the near future, distant future?
Well, of course, I have no idea how long I'm going to live, because I don't know how soon these therapies are going to come to fruition. What we do is this early stage, basic, experimental work that is inherently speculative in terms of its time frame. So I think we have a 50-50 chance of getting to this kind of well, the point which I've called longevity escape velocity, the point where the therapies are sufficiently comprehensive that we are able to stay one step ahead of the problem. I currently think that we have a 50-50 chance of getting to that point within about 17 years from now. But, that's, there's a lot of uncertainty about that. I think we have at least a 10% chance of not getting there for 100 years. So, that means that if you look at me, I'm 56, I'm doing very well for my age. So on the basis of that probability distribution, I probably have a 50% chance of making the cut. But I don't really think about that very much, because for me, the priority is the humanitarian one. The fact that every single day that I can bring forward the defeat of aging is 100,000 lives saved, literally, 110,000 more like something like 70% of all deaths worldwide. About 155,000 people die each day worldwide, and 110,000 or so of them die of causes that only older people die of, which means they die of aging.
Mm-hmm. If some solutions will come along which can help reverse aging, do you think it will create a population overgrowth and will create issues with this?
Yeah, so this is possibly the single most popular concern that people raise when we consider the possibility of eliminating aging. And, I could get angry about this, but I don't know. I mean, on the one hand, it's fairly shocking that one would say, oh, it's better to let people get sick and die rather than to have fewer kids than we would like. I think that's extraordinary. And I'm quite sure that if humanity were really genuinely faced with that choice, they would choose to have fewer kids. However, what's more important is that we're not going to be faced with this choice, because the rate at which the population would grow, even if we completely eliminated all death tomorrow, from aging and from everything else, is actually not as scary as most people imagine. And in particular, it will be massively outrun by the rate at which the carrying capacity of the Earth will grow. So, of course, the carrying capacity is defined as the number of people that we can have on the planet without an unacceptable level of environmental impact. And as of today, therefore, we have an overpopulation problem because, of course, we're seeing climate change, especially. But that's the point. We're not seeing any kind of difficulty in terms of how much space we have. Literally the number of people on the planet is less than the number of acres on the planet. So every single person could have more than an acre. But in terms of pollution, of course, we do have a problem. We're pumping out far too much greenhouse gas and so on. So then the question then is, how is that going to be tackled? And the thing is, we're already tackling it. It's not even a matter of speculation of early stage research the way our stuff is. Solar energy and wind energy are now becoming cheaper than fossil fuels, which means they're going to take over even if we continue to be really complacent about climate change and not actually to try to do much about it. And similarly, agriculture. So at the moment, we have a great deal of space and also a great deal of pollution that's occupied by agriculture, including, of course, enormous amounts of greenhouse gases. But again, artificial meat, certainly by 17 years from now, which I'm talking about, is going to be both cheaper and tastier than regular meat. And so again, far less pollution. And of course, there's many other examples. Desalination, for example, making fresh water available much more freely than now. And bacteria that eat plastics and things like that. These things are all coming now. So the idea of overpopulation being a problem is really just misplaced. It's something that the answers are obvious and they're easy. So I guess the thing that does frustrate me is that I've been telling people this over and over again on camera and on stage for years and years and years, and people just seem not to want to remember the answer.
Uh-huh. Interesting. You said they discovered some bacteria that eat plastic. I'm just wondering.
That wasn't us, but
I know. It wasn't you. But what do you know about it? If it's just interesting.
Well, yeah, you can do a lot with bacteria. So bacteria are incredibly diverse, and they evolve on the basis of what they need to grow with. So, for example, if bacteria are in an environment where there's a particular unusual molecule, then they will try to break it down so that they can extract energy from it or can extract, particular chemicals. And this has been exploited very effectively in terms of environmental decontamination, not exactly in terms of getting rid of inert things like plastics, but especially in terms of getting rid of toxic stuff like explosives or dioxins or whatever. This whole field has a name. It's called bioremediation. And it's not just an academic concept, it's been a very successful, thriving commercial concept for decades now. It really works.
Interesting. So how important do you think diet is in keeping yourself healthy or helping yourself live longer from 1 to 10? Like, do you think diet doesn't really play a big role in having a healthy, long lifespan?
So this kind of comes back to what I was saying earlier on about doing what your mother told you to. The impact of diet on one's longevity is rather the same as the impact of other aspects of lifestyle. It's not linear. In other words, if you look at if you consider three different people, and one of them is doing what their mother told them to, but pretty much nothing else, and one of them is living a bad lifestyle, smoking maybe, or going to McDonald's every day and relying on that for their food. And then someone else is doing everything they can, reading on the internet all the time and coming up with, supplements to take and so on. Then the person with the bad lifestyle may have a considerably shorter lifespan than the person in the middle. But the person who's constantly trying to find the newest best thing to do will only have a very, very slightly longer lifespan, if they're lucky, than the person in the middle.
Mm-hmm. So the difference, in your opinion, is just that good lifestyle and good food will make a person live longer, but it's probably 10, 50%, like not something dramatical like doubling or really reversing aging like some of the research are doing.
Not even 10 or 15%, a couple of percent if you're lucky.
A couple of percent. Interesting. So what diet do you choose to eat, if I may ask?
I'm one of those lucky people. I can eat and drink exactly what I like and nothing happens. I don't even have to do much exercise. So, I'm not an example to look at. I'm just one of those genetically lucky people.
Mm-hmm. Got it. Interesting. So in terms of aging, what do you, in order to get like more anti-aging, do you think it's easier doing it by slowing the aging process, which you mentioned, since there are things which help you age, or by helping and doing more repair of all the destroyed molecules and cells which someone has?
Yeah, like I said earlier, repair is actually easier. And this is perhaps counterintuitive, and that's maybe why it was overlooked for a long time. But the fact is, if we wanted to slow down the rate at which the body generates damage, then we have to manipulate our metabolism in some way, just essentially make our bodies run more cleanly. And that is just incredibly hard because, our metabolism is an extraordinarily intricate network of interconnected processes. And, it's like uncommented spaghetti code. There is just no way that we can tweak it to stop it from doing the thing we don't want it to do, the creation of damage, without at the same time, stopping it from doing things we need it to do to keep us alive. And in fact, it's even worse than that, because that's just about the stuff that we know about how the body works, how metabolism works. And any biologist will agree that that is completely dwarfed by the astronomical amount that we don't know about how the body works. So yeah, basically it's just a non-starter. Whereas repairing damage is much easier because until the damage reaches this threshold level that the body is unable to work around, in other words, late in life, the damage is essentially inert. It's not participating in metabolism, which means that we can target it and eliminate it without interfering with this network of processes that we don't understand. And that's why it's so much easier.
Mm-hmm. What are your thoughts on some things, I don't know, for example, infrared sauna, like before the call, actually I've made an infrared sauna, or things like hyperbaric chamber oxygen, or a few different tools which are out there, which do help people to detox in general, basically remove and repair. I think those are what they're doing. What do you think about some of those kind of therapies which are available, I think, really to the general population?
So some of these therapies may be slightly useful. As I mentioned earlier, there are some things we can do which will be slightly useful for some people. However, it's important to recognize that they're not really addressing the core problem of aging. In the body, there are these various types of damage that we work on, which accumulate inexorably because once they've been created, there is simply nothing in the body, no genetic machinery that has the capacity to eliminate them. But then on top of that, there's other kind of what I like to call pre-damage, essentially molecular species, molecular changes and cellular changes that are kind of on the way to damage. And the body does have mechanisms for repairing them. It's just that the mechanisms are not perfect. And so some of the damage kind of matures into this completely immutable form at the end stage. And so this kind of intermediate damage, pre-damage, is in general something that can be somewhat addressed by therapies that exist today. Essentially, these therapies, if you like, they enhance the intensity of the processes that the body already has to try to repair those things. And so one can, in that way, slightly slow down the creation of the final product damage that nothing can be done about.
Mm-hmm. So if they, like example of such therapies, they don't target the core of aging, what does target the core of aging, and what really is the core which makes people age?
Right. So I've given a bunch of examples already. Right?
Yeah.
I mean, the core of aging, the various types of completely immutable molecular and cellular damage that we simply need therapies to fix rather than anything to do with diet or lifestyle. Those things I normally classify into these 7 categories, and I've gone through several of those categories already and talked about the work that we've succeeded in doing that has led either already or shortly to clinical trials. Those are the things that matter.
Mm-hmm. Got it. What do you think is the biggest obstacle which we have right now, which stops us from researching the anti-aging faster around the world, including what you guys are doing and what other people are researching on various things in this field?
Oh, that's an easy question to answer. The thing that's slowing us down the most is lack of money. The fact that this research is vastly under-resourced, and biomedical research is expensive. It just is. So we definitely could be going much faster if we had more funds. And I'm not just talking about SENS Research Foundation, I'm talking about all of the research that's being done around the world. That problem is getting better in some ways, but only patchily. There are certain areas where, as I've mentioned, people have now decided these are investable, and so they're actually be able to move into startup companies that can get substantially greater financial support. But there are other areas which have not got that far yet, and so they're still relying entirely on non-profit, philanthropic or government support. And that's woefully inadequate. So we need to ask, why is that? Why doesn't the world wake up and actually do something about this? And I believe that fundamentally the reason is the same reason why people, keep coming up with the same tired old concerns like overpopulation, despite the fact that I have rebutted those concerns over and over again for a decade or more, and other people have done the same. The fundamental thing is psychological, that, we have had to cope with aging since the beginning of civilization, and we've had to find some way to put it out of our minds and get on with our miserably short lives, and, not be preoccupied by this terrible thing that's going to happen to us late in life. And the only way we've been able to do that is to make up these crazy fictitious arguments that aging is some kind of blessing in disguise, and that we shouldn't be messing with it, or else that somehow aging is off limits to medicine and it's inherently impossible to address it with medicine, which is also complete nonsense. So yeah, basically it's all just psychology, unwillingness to get our hopes up, really. And the more we can break that down and get at least some people, preferably some people with money, to actually be realistic about this and to support this research more powerfully, the more lives we will save. It's as simple as that.
How do you think we can raise the awareness of people to want to live longer, I'm guessing naturally people do want to live longer, but I'm curious, what do you think about it?
Well, you're doing it right now, aren't you? You're getting me on camera. That's
Yes.
definitely one of the most important things, is just to get the word out and get people to be more knowledgeable about this and to understand that the initial knee-jerk reaction to the idea of bringing aging under medical control is poorly thought out, and that they need to think more intelligently about it. Yeah, I mean, really, you know, it's just a matter of repeat advertising, a matter of getting out there and getting people to understand what's going on. Plus, of course, even with the very limited resources that are available to this research at the moment, we have made considerable progress. And every piece of progress that's made gets out there and gets on the front page of the newspapers, and that is definitely important too. It's another example, another demonstration of the contradictory frame of mind that people have, that even though they kind of say that they don't want this, or that they think it would be a bad idea, nevertheless they're fascinated by it, and you know, that's why it's constantly in the news. Which, if you ask people how long they want to live, that's a dangerous question to ask, because it doesn't incorporate the scenario of what that life will be like. And so it allows people to interpret the question as, would you like to stay alive for a really long time in a bad state of health, in the state of health that is typical of older people today? When, of course, that's not the prospect that we're talking about. The prospect we're talking about is keeping people alive in a youthful state of health for as long as they like. And then you get a very different answer.
Mm-hmm. What do you think is the potential? I know you didn't get there, but based on your research, until which age maybe people can live, assuming some of those developments will come into fruition? What do you think is the potential? Like, can we live forever? Will people reverse their aging? What do you think will be happening potentially in the future?
Yeah, so I've already answered that. I mean, yes, this is going to be about reversing biological age, actually rejuvenating people, taking people who are already biologically 60 or 70 or older, and actually turning them into people who are biologically 30 again. So that means, of course, that people will, on average, live a great deal longer. The risk of, I mean, most people die from being sick, and the main reason why people get sick these days is by having been born a long time ago. So if we can break that link, if we can make sure that people who were born a long time ago are not sick, then clearly their expected lifespan will be much longer. Now, of course, there's no such thing as immortality. We know perfectly well that there are always going to be other causes of death, whether it's being hit by a truck or whatever. But those causes of death will also have diminishing rates, because we will work on them too. You know, we're getting self-driving cars and so on. So there is no way that one can put a number on how long people will on average live.
Mm-hmm. Interesting. Is there anything notable which you're doing maybe for your health, putting aside diet in terms of lifestyle, or really any other component, something which you think is worth sharing?
No, I just, you know, I spend my life trying to hasten the defeat of aging. So I guess that's really what I'm doing for my health. It's the only thing we can do right now to increase one's chances of benefiting from these therapies is to make them happen more quickly. And that's, of course, true not only for me, but also for you. You know, you're doing it by putting me on camera, and anyone who puts me on stage, or anyone who is a biologist themselves and they are choosing which research field to get into, or anyone who's a billionaire, of course, or indeed anyone who's not a billionaire, because every penny counts. So, you know, that's the way to save lives.
Got it. Very interesting. So what do you think is the biggest breakthrough which you guys had in your research, which you can share? Like maybe the number one thing which was the most fascinating, or where you think really this was the biggest breakthrough you had so far in what you're working on?
Yeah, we can't really say that there's a number one breakthrough, simply because the nature of the problem is that there are these many different types of damage that are accumulating in the body, and they can all kill us on schedule, right? So basically, if we fix most of them, but not all of them, then we're not going to have all that much benefit in terms of how long people will stay healthy, and therefore how long they will live. Which means that our focus is on, you know, we prioritize the most neglected areas, the areas that other people are not working on so much, so that they can, if you like, catch up and get to the point where we can repair those types of damage as well. And as such, we don't like to think in terms of one type of damage being more important than another, only we just want to make sure that we don't get to that unfortunate situation in which we can fix most of the types of damage, but there is some holdout type that we can't fix yet, and so everyone's still dying on schedule.
Mm-hmm. Okay. Do you think there's any difference in those therapies for people who will start doing it at the age of 40 versus someone who will start doing it very early in life, let's say age 10 or 15, like adolescence? Will it create like different lifespans based on when someone starts doing something?
That's a great question. That's a great question. No, there will not be a difference. And of course, we can see this immediately if we think about what the concept is here, the repair of damage. So, I mean, think about a car, for example. There are cars running around today that are 100 years old and that are working every bit as well as when they were built. But that's not because those cars started being, maintained and, with preventative maintenance measures the day they were built. Maybe it was a few years before they accumulated enough damage for it to be even worthwhile to eliminate some of that damage. So if you just do it periodically and you make sure that the damage does not reach the level that exceeds what the body is able to tolerate, then you're fine. That means that starting at age 50 or 60 is going to be just as good as starting at age 10. Mm-hmm. In fact, you could argue that it's better than starting at age 10 because, of course, at age 10, you're wasting 50 years of progress. The longer you wait, the more effective and safe and so on the therapies are going to become. And so the trade-off, even if there were much of a trade-off, is very much in favor of waiting until you're nearly old enough to need the therapies so that you can use therapies of the highest quality.
Mm-hmm. I know we already covered it, but I think it may be beneficial to go for it just a bit again. Like, what are some of those therapies which you think may be able to achieve the result, which right now you're working on? Can you specify maybe them again?
So maybe I can answer the question in a different way, because a lot of things that people are interested in are how the therapies will actually appear from the point of view of the patient, the person who's receiving the therapy. And I've emphasized already so much that this is a divide and conquer problem, that we've got a lot of different types of damage that we need to repair, which means, of course, that we're going to need a lot of different therapies. But actually, it probably isn't going to seem that way from the point of view of the person who's receiving the therapies. It's really going to be an extension of the concept that we have already with, for example, the MMR vaccine. So the MMR vaccine is just one injection, but it's not actually one vaccine, it's 3 vaccines for different diseases. And so I can very much imagine that we're going to be in a situation 20 years from now where people get one injection, but it's got 300 different treatments in it. Some of them will be stem cells, some of them will be engineered DNA for gene therapy, some of them will be immune therapies, but you'll get them all injected into the circulation and it'll feel like one therapy.
Mm-hmm. So do you think it's going to come in the form of a pill or just in the form of injection or in the form of device which you need to buy, which may help you recover, or all of them? How do you envision?
That's probably going to change over time, but I think it's pretty fair to say that most of this, at least, will be supplied by injections. Generally, things that are supplied as pills by oral administration, there are inherent limitations to what can be done with that, because anything that goes into the stomach has to get out into the circulation somehow, and it's at risk of being broken down before it does. So getting it into the bloodstream directly with an injection is going to be more straightforward. Early on, when these therapies first come along, it's quite possible that we will need actually to involve surgery in some cases, replacing whole organs with artificial ones that have been built in the laboratory, for example. But of course, that's much more invasive and arduous and can't really be applied to people who are already frail. So that will be only very much a temporary phase. I'm sure there will be very intensive work to phase that out in favor of less invasive things like injections as soon as possible.
Mm-hmm. Got it. Aubrey, we are getting close to the time we have today in the show. I'm wondering if there's anything else you think worth sharing on the topic kind of aging of what we discussed today.
Well, not really. I think you've covered the most important things. The state of the research, importantly, and of course the rate at which the research is progressing. And I thank you for giving me the opportunity to emphasize that the main thing that people can do right now to help themselves and to help their loved ones is to support the research in whatever way they can, whether with their time, their money, or whatever, and to get it to happen faster. Of course, we have a website, sens.org, SENS.org, that is very informative. We've got information there for everybody, from experts all the way down to complete novices, on what we're doing and also what other people around the world are doing to make this rejuvenation biotechnology a reality. And I very much encourage people to go there. If there's anything that you want to say to us, then we have a contact form there. You can write to us. You can contact me personally that way. And for that matter, we've also got a nice, friendly donate button. So that's definitely what I encourage people to do.
Got it. I will make sure to put all those links in the show notes for people listening in. If anyone wants to check SENS websites, and if you choose to donate money, I'll leave all in the show notes. So Aubrey, thank you very much for taking the time and sharing more about what you think we can do potentially with a human lifespan and kind of what you found with your research so far. So I appreciate you taking the time.
Well, thank you again for having me on the show.
Yeah, thanks for coming.